innovations in training using artificial intelligence and machine learning. A very emergent area, and we're lucky to have a couple of real experts in this space talking to us today. I wanted to extend a warm welcome to other CAE staff who are joining us here today, but also welcome our UNSW staff and students and alumni, and many of you who have joined us from industry or outside the university system. So it's great to see you all here today. So CAE is a high technology company and a global leader in the provision of simulation and training services for aviation, healthcare, defence and security. Now, interestingly, they're also partners with UNSW on a Master of Visualization and Simulation program that we have running through the Faculty of Arts, Design and Architecture. So it's fantastic to be able to partner with such a company to bring real-world industry insights into the curriculum to support our students and to help shape the future of industry practice. We're hoping to make this event a regular one, so we'd love to see you at more of these. But without further ado, I'd just like to get started by acknowledging, doing a quick acknowledgement of country. So UNSW Sydney acknowledges the unceded territory of the Bedegal people from the Kensington campus, which is the main campus of the university, Gadigal from Paddington in Sydney, and Ngunnawal from Canberra, who are the traditional owners of the lands where all of our campuses are. We'd like to pay our respects to any past and present leaders and elders and extend those respects to anyone present here today. So, quickly, I'd just like to introduce our two speakers and then quickly just do some housekeeping and hand over to them. So joining us today, we have Justin Newman, and Justin Newman is the Regional Director of Human Resources for CAE, who started his career over 25 years ago working in retail, where he realised he was more interested in talking to customers than trying to sell to them. Since that time, he's held a number of HR leadership positions with Wesfarmers, including time at Bunnings and their industrial safety divisions. His current role with CAE, Justin and his team support those who look after CAE's customers and are responsible for the innovations that continue to drive CAE's growth and development. So while Justin enjoys playing in all of the simulators, his focus is now on those who create and run them. Joining Justin, we have Dr. Gary Eves. Now, Gary has spent 30 years working in simulation technologies and has developed and used simulation in flight, both civil and military, driving, virtual reality, energy with oil and gas, manufacturing, entertainment, defense technologies, and more recently, healthcare. His doctorate is in the validation of serious game-based simulations for developing technical and non-technical skills, and his current role in CAE Defence and Security is to develop novel customer solutions combining VR, AR, and synthetic environments. Now, coincidentally, Gary is also working with UNSW. He's helped co-develop some of our courses in the master's program, and he is teaching our students as well as playing this vital role in CAE. So really quickly, some housekeeping notes, and then I'll hand over to Justin and Gary. Just want to let everybody know that this event is recorded, and we will share the link after the event. So please be aware it's recorded and make sure you're comfortable with that before asking any questions, etc. at the end. We're going to have CAE present for around about 40 minutes. Then we're going to have a Q&A that will be open to everybody. And we ask you to participate by adding questions at any time in the chat function. And I'll collate those at the end and I'll facilitate that Q&A at the end. So please hold the questions until then, but make sure you jot them down when you think of them in the chat. And lastly, at the end of the session, we are going to be giving you a link to a quick 60-second survey because we really want your feedback on this experience to help us plan more events in the future. So, without further ado, I'd really like to say a warm welcome to CAE, to Gary and Justin, and I'll hand over to you now to take us through your presentation. Thanks very much.
Thank you, Simon, and welcome everyone. So I am Justin. So as Simon introduced, I'm the Regional HR Director for CAE, and thank you to all students, staff and faculty of University of New South Wales for arranging this and having us here today, as well as those from CAE and industry who've joined us for what we think is going to be a really exciting and interesting conversation. And a special thank you to Remy and Teresa, who have helped pull all this together behind the scenes. But before we get into the detail of machine learning and AI, which Gary will be taking us through, we thought it would be helpful to start by giving you an overview as to exactly who CAE are and exactly what it is we do. If we could move to the next slide, please, Gary. So, as Simon touched on, we are a high technology company. We were founded in 1947 in Canada by a Canadian Air Force veteran who wanted to create something that, as he described it, was extremely innovative and very technology intensive. We're a values-based organisation that really is actually about people and helping them perform at their best. We utilise technology and invest in innovation to actually achieve that outcome. Whether those people are our customers or our employees, really our focus is help them achieve results and get better at what it is they want to do. So in essence, we use digitally immersive solutions to improve safety, efficiency, and readiness. And it's one thing for me to describe it, it's another thing to see it for yourself. So if Gary, I could ask you to move to the next slide where we can show exactly what we do best. So what you've seen there is in essence is CAE in action. So we have three key business units globally. There is defence and security, in essence civil aviation, as well as healthcare. And in essence, we provide training and simulation services that really are about making our customers and supporting our customers perform at their best. So how do we make it happen? It's really a combination of knowledge, which really is coming from our teams, being a leader in our industry, which is being an industrial champion, along with the adoption and creation of advanced technology. And it's really the marriage of these three elements that create that seamless environment that really allow our customers to suspend disbelief, if you will, and learn real world skills and gain practical experience in simulated environments. If we could move to the next slide, please, Gary. As I touched on at the start, we are a global organization. The benefit of that, of course, is all the different experiences we can gain from our teams all over the world, who, whilst we face different challenges, our desire to innovate, improve, look after our customers actually unites us. So that global experience actually really helps with the industrial championing because we can learn from each other and from that improve things for our customers. So as you can see there, you could see we have about 170 actual aircraft and over 300 odd simulators placed around the world. In essence, we serve the healthcare industry, and Gary will talk more about that in some more detail about how we can train people, in essence, get them literally ready for surgery, as well as provide services to both defence and security, so such as military flight training devices, as well as the civil aviation industry. So if any of you, as I'm sure many of you have been on any commercial airlines, there's a fair chance that one of you, at least one or two of your pilots would have been in a CAE simulator or trained by CAE. So hopefully that gives you a better overview of what we do and who we are. If we could move to the next slide, please, Gary. And just finally, I just wanted to touch on who we are locally. So, closer to home within the Asia Pacific region, we have extensive operations across Australia, both in civil and defence. And we are expanding into New Zealand, along with having operations across Singapore, India, and Brunei. So what I would like to do now is hand over to Dr. Gary Eves, who is our Business Development Manager and Engineering Technologist, who will be talking to you about what we're really all here for today, which is about AI and machine learning. So over to you. Thanks, Gary.
Thanks, Justin. Good afternoon, everybody. Welcome. Thanks for spending your time with us. So as Justin said, I'm going to try and illustrate a few key points from what we do in the civil, the defence and the healthcare sector. But in many respects, when we're looking at what we're trying to do with simulation, we have to really quite carefully think about and understand what's the training problem we're trying to solve. And more often than not, we always think about this in terms of training the end user. There was a fascinating article just published a couple of weeks ago, and The Economist talking about, is it EdTech or tech ed? Which comes first? Should we be using this technology to train our end users, but also should we be using it to train our educators as well? So there's an interesting thought there to think about when we go through this and the adaptation of the technology to high-tech education. Because it's not just about the end user, but there are commonalities within that. We've got overloaded instructors who are our guiding lights in this. They're the knowledge that we want to capture into these systems so that we can automatically assess people. They're a rare resource, and we've got to try and find a way of capturing their knowledge, easing the workload on them, and embedding that into training systems and delivery mechanisms that meet the changing demographic of who is moving through our educational systems. We see this absolutely core to our business going forwards. The embodiment of the ability to capture performance data, to analyze that data and enhance it with artificial intelligence and machine learning, apply that to the science of delivery of the learning outcome, and then report on that effectively, such that we know that we are doing the right thing. Because so often we get into these, we develop these capabilities and we get into these programs, and we don't actually think about and prepare for the ability to capture metrics on how we are doing as educators and how the students are doing in their learning experience. It's absolutely critical. Otherwise, you could almost argue that we're not doing the job properly. Could almost be wasting our time if we don't feed back on what we're doing. So, but before we get into some of that, there are some challenges and questions that we need to ask ourselves about what we're doing with simulation and simulators. Fidelity. There's always a huge debate about the fidelity that's required to deliver a training task. And we tend to gravitate towards the highest level of fidelity, and that's a very expensive thing to do. I've seen sonographers give really great training in ultrasound and guided insertion of a needle with a foreign body in a chicken breast. And that's really low fidelity, but it delivered a great training outcome. And we go right the way through the other end of the spectrum, where we've got human patient simulators at the highest end of our capability that have an enhanced physiology model in them, and you can give them a real anesthetic gas and you can kill them. And that's right at the end of that extreme. And flight simulation, again, is a perfect example. But more often than not, there's nothing that actually states, except perhaps in the civil arena, what the fidelity capability has to be. And then if we look at validity, we've actually got to make sure that these things actually meet the task at hand. So do they look like the real thing? Do they behave like the real thing? And when you are using them, behaving them, are they sensitive enough to differentiate between novice and experts? And that relies on very careful design of the simulation, careful design of the capturing of metrics of interaction with the simulator, and then reporting on it in a meaningful way. None of those things will work unless the student who is engaging with the simulator appreciates the relevance of the task or the mechanism which you are trying to engage with them. If you teach them something that's completely, if you use a mechanism that's completely abstract, they can't relate to, they're not going to be engaged in it, they're not going to go back and repeat it, and they're not going to go through a repetition of learning cycle that we want them to engage with. We also have to think about what skills we're trying to measure. Technical ones are easier, because they have some metrics associated with some degree of performance. But if you're looking at non-technical skills like communication skills, leadership, situational awareness, they're much more challenging to do. In healthcare, when they're looking at some of those skills, they might actually film a scenario and observe where the lead clinician is looking and interacting and who he's talking to or she is talking to within a scenario. But that's about as far as it goes. And the only metric they apply to that is some sort of ranking of, did they look at person A, did they look at person B, and maybe for how long. When we get into using these simulators, we still haven't adequately answered the question around how much is enough. We don't know exactly how much training is enough to achieve some degree of competency or confidence in using the task. We don't know how frequently we should be doing this training. And we don't know what the period is between training cycles to get somebody to mastery, and you'll hear about that a little bit later on in the presentation, and then how to maintain mastery. All of that needs to be wrapped up within understanding who we're trying to train, what they are going to be expecting from us as educators, and the delivery mechanism that we provide them with. We have to think about the general shortage of instructors. And that will probably only get worse. And we have to think about a way of capturing the gold standard, the knowledge that they have, and embedding that within the simulators that we're making. And when we do embed that knowledge in the simulators, how do we use that to provide feedback on the trainees that are going through the system? And generally feedback is sort of either hot or cold. It's during the activity, or cold when it's after the activity. If you got it during the activity, is that a good thing? Do you want to stop someone from doing something, correct them, and then have them continue, or do you let them continue to the end of the task and then provide them with some feedback such they can reflect on that and go back and go through that whole learning cycle? There's no definitive answer on what that should do. And that leads us into the debriefing and assessment metrics. Should debriefing be done hot? Should you stop the activity, provide some constructive feedback, allow for some reflection and move on again, or proceed to the end? And then what sort of assessment metrics are we going to do? And what is the impact of providing someone with hard, cold data on their performance in terms of what that might have in their motivation and their willingness to continue? So there are a few thoughts that we need to hold in the back of our mind when we're looking at some of these examples. In terms of examples, I've got a couple here from medical. The top one is minimally invasive surgery. That's a laparoscopic simulator. And some of the early tasks in that are around picking and placing objects. So basic motor skills, going right the way through to actually completing, say, an appendectomy. Some of the metrics that are used in that are time to complete surgery. And you have to ask yourself whether that's really a sensible metric to try and provide feedback on, when someone might be encouraged to rush through a procedure just to get a good time. It needs thinking about. Colonoscopy, pain-free insertion is probably an obvious one that you might come up, and it does have a forced feedback mechanism. But the real trick in providing a good, thorough examination is making sure you don't get lost in the colon. And literally you can end up inserting the probe, wandering around inside, and getting trapped because it's a big square and lots of little squiggly bits, and then actually coming back out to get a retroflexion view so you can see the outside world from the inside. They are all key performance parameters, but how would you measure them in a meaningful way and provide data for the engine that might be used in an AI assisted situation? When you look at non-technical skills, you've got situational awareness. Has often been described as a good benefit of simulation-based training. But again, how would you measure that? And we're going to show you an example from civil and military aviation in a minute. Leadership, again, really challenging one. How would you apply a meaningful metric to leadership and be able to collect data with confidence such that you could make a decision over somebody's competency in a task with a proxy measure of leadership? So we also have to remember, what are we going to be using this data for when we put people through these simulators? Are we selecting them before they progress into a training program? So it's aptitude assessment. Once they're in the program, are we using it to identify those that are top performers, those that need remedial training? And if they do either perform really well or need assistance in training, what adaptive learning strategies, i.e. remedial training activities or accelerated training activities, do we provide them? And what standard is that done to? And then how do we go through the process of using that data in the simulator to maintain that standard, and then developing the cycle of training to achieve concurrency? That's done in civil, where they go through their training twice a year, but in healthcare, certainly not done. And I'm sure there's a strong resistance to people being recertified in the healthcare industry. Now, when we've applied this approach to aviation training, and this concept can be applied to a lot of others, you can have a desktop self-paced type environment. So you're using low-tech, low-fidelity units, PC-based, virtual reality delivered content, nice interaction, appeals to the demographic, and you can have a virtual instructor within that who can be monitoring some basic level of performance and then providing feedback in a hot or a cold format. You can then move up the fidelity scale, and here you've got an augmented reality situation, virtual reality situation. Again, you've got a pilot in a chair, and I'll show you a video of this in a bit, and he will be able to see a cockpit. So we've moved up the fidelity level, we've moved up the stakes in terms of assessment, and we are now providing real flying data metrics to the candidate and the assessment criteria. And then they get into the perform aspect, where they might move into the very highest fidelity simulator or the real plane. And this is the point at which we bring the real instructor in. And this is the point at which that instructor can provide to draw upon the AI data and then apply their expert opinion to that as a base level of assessment. Now, normally when we show this slide to customers, that middle area is blued out with a big blue box that just says AI. And the reason I've included it in there is to show you there's actually a lot that needs to be considered in terms of building up a system, in terms of capturing the data. When you've got the data, what sort of grading process did you apply for it? What happens when you do apply that grading process and someone flops into one side or other of the boundary of the grades? What sort of curriculum do you move them through? How do you prove competency in that new curriculum and move them on? And they're all the steps that are embedded in that. I'm not expecting you to read it clearly now, but it's just simply there to show you it's not quite as clear and easy as you might actually think. Sorry, a bit of a build there. Now, what we do with that data when we capture it is we've got to provide it in a format that is easy for the candidate to understand. So there's this relevance situation again, and for the instructor to draw upon. And we've done that within a product we call Rise, and basically it captures data from the simulator per candidate, per procedure, per class, per cohort, and presents that in a number of different ways, such you can build up a mapping of individual performance against trends and standards. Now, some of that standard development, forgive me while I build the slide, is actually easier done in circumstances like civil training, where you've got standard operating procedures that are clearly defined, that indicate steps of process, and you've got metrics that can come out of the simulator that you can use to assess individual performance against. And this makes the whole building of the AI engine and the machine learning capability a whole load easier. And I'll just draw your attention to the green bars in the middle. There are a number of different performance attributes of the aircraft down there. They come from the aircraft manufacturer, and then you can see these boundary conditions of certain attributes of aircraft performance and where the candidate might sit within the middle. Great when you've got something that is data rich as an aircraft, but what happens when you think back to the colonoscopy simulation I started with? Where are the manufacturer's performance data for colon insertion in your average human being? They're not there. So we would have to come up with some sort of measure that's going to enable us to build a similar type of graded bar chart that would help me understand how I'm doing in that procedure, and then help the instructor guide me through to do it in a better way. So you can see we're some areas are data rich, other areas are data poor. When you do get that data, you've got to present it in a way that can be used to inform the trainee, but also validate what the instructor has done. Now, I'm not expecting you to look at the data too deeply, but basically this is where the aircraft makes contact with the runway, and you can see some outliers here of performance. Now, the green ones are obviously quite bad, but the pink ones there, they are where an instructor has said that particular trainee's performance was acceptable. So clearly there's a discrepancy between what the data is telling us and what the subjective assessment of the instructor is telling us. And we need to be aware of this potential for conflict when we're collecting data and using that data to make assessments on performance. And there's another example here where you can see you've even got some more extreme boundary conditions of where an instructor has said these things are okay, but the data and the machine is saying they're not. So when we're implementing these systems, be aware of how we're going to deal with that potential for conflict. One of the very interesting metric that is being used at the moment in biometric is called gaze tracking. It's applied in our civil simulators, and here we've got a little video from RAF where showing how they are applying it in their flight training simulators.
The Institute of Aviation Medicine wanted to see if eye tracking technology would be usable in an aviation training context. And we were lucky enough to host the trial in the Hawk simulator. The system uses 2 IR lights to flood the pilot and an IR camera to detect exactly where his gaze and his pupils are looking inside the head-up display to look at the speed and the height and etc. and weapon aiming and like. But it's also usable down in the cockpit, which is looking down at some head-down displays for fuel, engine performance, that sort of information. By seeing exactly where the pilot is looking at, you can see what they're thinking about, and therefore you know how to instruct them better. Simulators right now aren't built with eye trackers as standard as part of their baseline, but in the future I think they will all be built with eye tracking as part of the baseline because it is so helpful to the instructor. Going forward, we'd really like to keep the system in our simulator, and in fact we'd like to fit it to all 3 of our simulators, and we're starting to look at plans to do that. But in particular, we think it's going to be important for the rest of the flying training system, so we're going to speak to them about it too.
Okay, so there we go. So what that means is whilst the user is working with the system, the camera is recording where they're looking. So you can see now that there's a little flicker moving over those controls. That's his eye position, and you'll see the boxes get illuminated when his gaze lands on one of those instrument panels. That's recorded in this candy bar here, so that gives the trainer an idea of what he's looking at in a particular maneuver, for how long he's looking at it for, and then what's the flicker rate in between them. And pupil flicker rate and pupil dilation, which the cameras can also measure, are very strong indicators of situational awareness and cognitive overload. So we can get to the point where we can use the data to find out exactly how far we can push a candidate to help them achieve peak performance. And most of your commercial VR headsets and augmented reality headsets have that capability embedded within them. So now we're just going to look at a couple of other examples in healthcare. Now I'm going to show you a video from Rolando Del Maestro's team in Canada, where they're using the Neuro simulator. Now I might just have to make sure I switch my screen here, so bear with me one moment. So the interesting point that they have done there is that they have not, I'm going to have to whiz forward now. They have not attempted to use it as a means of assessing the end skill, although they have included that as part of the metric. They were using it to differentiate skill levels and had come up with a mechanism. Forgive me while I page through here. Didn't think that would work like that. They've done it as a means of trying to identify where somebody sits on this curve. And this curve is just surgical performance versus age. And if you look at here, the interesting point is when they start, there's a 20-year gap between when they get to peak performance. And I'm sure most of us would appreciate that's probably, we benefit from it because we get an expert doing our brain surgery. But really, in terms of a general education methodology, it's far too long. So what they want to try and do, and what we want to try and do with this technology, is to steepen that curve, drag it forwards, and then flatten the curve such that we don't have this degradation below the required performance. And that can be done through capturing the data, modifying training scenarios and delivery accordingly to make sure that we get people to that peak performance that we desire sooner and more efficiently. And that will be delivered by the different levels of fidelity of simulator we use, and the application of appropriate metrics to be measuring performance. And when you look at the metrics that they were capturing and presenting, they weren't blood loss, they weren't efficacy in removing tumor. It was the pressure they were applying during the simulation. So you can see here on the left-hand side, the 3D chart shows much less red than the right-hand chart here, where we've got an early learner working their through with this. So that's an interesting example of where you can actually put through a different metric. Now, unfortunately, I can't see my screen at the moment, but I'm going to show you how we do this in ultrasound in a moment. And you're going to hear from Robert Amiot, who actually invented the simulator that you're going to look at. He was a cardiologist. And the same data metrics are being captured and presented for sonography.
CAE Healthcare is the global training partner of choice to improve patient safety by providing training solutions based on simulation. As a healthcare provider, we're the most dangerous when we are into that learning curve. But now this has completely changed. What HoloLens has added is another layer. We can practice on plastic and pixels and see all the different cases and the challenges you can have. And then when you're ready, you can do these procedures on real patients. That's been a revolution.
We've got here a ultrasound simulator, replication of a body with the different probes that might use on it, and how that works and how we have supported the learning process at the beginning of the learning curve is by adding in augmented reality. So you can see here 3D images of rendered images of what the ultrasound probe should be showing you. And there's the cone, the arc of ultrasound. That's what the real ultrasound image actually looks like as it's being captured. And just 1 second more, and you can see the type of data that could be fed out from the simulator as a whole bunch of angular positions of the probe, time to acquire imageries, and they're the things that can be useful to improve trainee understanding of how they're performing, and not necessarily moving into the analysis of the image, which we often sort of hear about artificial intelligence being used to compare and contrast images that are captured from diagnostic tools like this. Now, what that simulator can output is a similar metric to the pressure argument that the neurosurgeons are using. It was the efficiency of path of moving the probe to acquire an image. And you can see here a novice trainee, very irregular, large path of movement. As somebody gets slightly more proficient, the boundary conditions of that path of movement are a little tighter. You compare that to an expert, even tighter still. Not an exact output of sonography proficiency, but a good proxy measure to show the development of competency through operating the real ultrasound device. This can also be applied in large-scale simulations. So when we look at what we call a single synthetic environment, which can have a multiplicity of different data feeds, including social media and discrete event simulations, all of these things are going to be enormously data rich and are going to need some degree of artificial intelligence to parse and synthesize and make relevant data to a particular user as they attempt to work with enormous data sets that are being presented to people in reality. So that's something that we're working on. We've just been given approval for a project today to look at using AI and augmented reality for data visualization of communication capability over large-scale terrain maps. So it's something that is happening now for us, and we're finding that really quite exciting. Now, in trying to close this down, if we're going to go this far in using this capability, we've got to consider use of proxy measures, as I've illustrated to you so far, in terms of like pressure and angular movement, because often we're not going to get the right sort of metrics out of the simulators that we have. We've got to consider how we're going to turn data lakes into databases. So we can collect lots of data. It could be meaningless. We've got to turn it into information that we can use for validation and modeling of performance. All of this doesn't come easy. Much more significant effort is involved in the planning and preparation of the capture, presentation, and reporting of information if we're going to make best use of this type of technology. And then we have to consider how we present that and whether it replaces or supports the instructor. And what are our assessment implications of this? If we're going for regulatory compliance, how is this going to be accepted by bodies out there who might have some degree of say in who passes and to what standard? And then what are the ethical considerations of using algorithms that are developed by someone somewhere to affect someone's ability to perform their task? So interesting thoughts, I think, that we need to be considering as we're moving through to some of those things.
The questions in closing, I guess the questions you posed at the end really are the kinds of things that we find fascinating and deal with every day. And I guess from a CAE perspective, as part of, we touched on at the very start, I talked about, being an industry champion and being actively involved in industry. We see partnerships with the likes of yourselves, University of New South Wales, and forums such as this is absolutely what these are about. At the end of the day, all of these are questions that need to be discussed and resolved. But I guess what I conclude with is the key to our success, and really everything that happens within CAE and with our customers, really comes down to our employees. So while certainly the technology is important and we absolutely can utilize it for all manner of things, how it's ultimately utilized, how it's interpreted, and how it is applied really comes down to really having the right people in the right place and having open discussions about these sorts of questions, and not just within ourselves, because we know we don't have the right answers, but it's engaging with people who are passionate and interested in these sorts of questions, such as yourselves. And we really see this forum as, if you will, almost the starting or kickoff point, if you will, for these sorts of conversations. And I know there's a number of questions in the chat around this. So I guess in closing, we'd say the technology is great. It's fascinating. We can do all sorts of things with it. How we do things and what we should be doing really comes down to our employees working with our customers, working with industry, and working with yourselves to come up with what is the right solution and how do we apply it to get the right outcomes. So Gary, thank you for your presentation, and Simon, I will hand back to you.
Thanks very much, Justin and Gary. It's phenomenal to see what you guys are doing at CAE at the moment, and to start to think about what some of the applications might be in a lot of what we're doing in higher education. I have a lot of questions, but we have some coming through the chat, so I may just go through some of those and see if I get to sneak my own in a little bit later. We had the first question from Teresa, and it was about how and where do we train instructors to interpret and use feedback data correctly? So it's one thing to get the data, but how do we tell people what it means?
Wow, I don't think we do. What do we do when we instruct and have we take an expert and we put them into a classroom and basically rely on their expertise to get on with it. We don't teach them how to teach. We don't teach them how to assess. We don't teach them how to give good feedback. Well, yes, we do, but we don't do it in the way in which I think it can best leverage the technology. We're not taught how to teach with simulation.
So there is actually a gap there that we need to actually address.
Yeah. It's a new paradigm.
Excellent. Okay. Thank you. And I have one from Julian, which is a tech-based question. Can data be sent to an LRS or XAPI?
Yes, essentially. Simply, yes. Yeah, I mean, all of these things have to be integrated with learning management systems and learning resource systems. So without that, that ability to turn the data lake into a database, it's sort of useless. And then the personalized records that can be used for reflection thereafter and improving skills, absolutely essential to track the development of competency. Otherwise, we won't know how people are getting up that curve that I showed you on one of the slides after the neurosurgery.
Yeah, so that's a fantastic thing, just to throw something in there, is that it's not just about data coming out of one simulation. There's a longitudinal sort of learning pathway that you can continue to build on and add to, which is
absolutely, because we have to manage the forgetting curve. We've got to get people to peak performance and keep them there.
Yep, fantastic. Teresa has asked several questions, so I've given her a turn. I may give other people a turn first and come back, Teresa, if that's okay. Nagita has asked a question, for measuring leadership and decision making, do you believe that there are intangible elements that can't be predicted by AI or measured? So surprising, e.g. surprising leadership styles, human relational factors, etc.
Wow, that's a tough one. I mean, decision making in a complex distributed environment is incredibly difficult to prepare a simulation for and to attempt to measure. And you've got so many disruptors that appear in the real world that affect someone's ability to make effective decisions. And then how would you record them and put them on a chart to show whether it's normal situation, highly stressful situation, or stressful because there was some other unpredicted interruption. You know, like you're in surgical theatre, everything's going to key, everybody's doing their roles. Then the phone rings on the wall. What happens? Does somebody stop and react to the phone? And that's an actual example from a clinical simulation I've been involved in. And it's thrown in there to cause that sort of disruptive influence on someone's decision making and their situational awareness.
And I guess the other thing that I'm thinking about as well is that we don't have to use the machine to measure everything. I think there's still a role of synthesizing these sorts of technology-driven simulation experiences with some more traditional debriefing and pedagogy kind of processes, so that you've got a spectrum of approaches you could use.
I think so. My personal view is that I think this technology and the raft of lower fidelity simulators have more validity at the beginnings of the learning curve. And so you let people explore, repeat, refine, use the supportive capability in that phase. Then when they're ready to exploit higher fidelity simulators, move them up. And in that point, that's when the real instructor comes in, because that's when they can put most value onto what's going on. It's gilding, you know, it's the finishing off.
Fantastic. A question from Nikki. Have you gotten any feedback from the participant neurosurgeons? And I guess, what was it?
I haven't, but if anybody wants, I'll send out the link to Rolando's site. He's got lots of good resources on there, papers he's published, videos. He's actually got a role in one of my lectures that I've given on there. Wonderful man, and he's happy to talk about any aspect of what he's doing. Very open with his capabilities.
Fantastic. And maybe if you share that link with us, we can distribute it with the recording. That would be fantastic.
Yeah.
Nikki asked a sort of follow-up question to that, actually, which is about, can you get the data of real performance of neurosurgeons, including failures? Nikki, do you want to clarify that question?
I think you're talking about validity at that moment, and just talking about checking on the real life performance, how they've gone after the training, and if it's helped them.
So the Neuro Simulator is probably at the very high end of fidelity and validity. The simulation you look at on screen is a wonderful replication of the brain and the surgical implements and the flooding of blood and the removal of tumor, the soft tissue deformation. So in terms of the user's perception, it's right on, and I'm sure they could translate that experience to the real one. In terms of like measuring success, that's a real tough one, because like what is success in a situation like that? You've got to define it if you're going to measure it. Is it percent removal of tumor? Is it minimal blood loss? Is it time to complete operation? What is it? I'm sure Rolando and his team went through that once they narrowed it down to those metrics they spoke about in terms of fluidity of hand movement, stability of hand movement, and then applied pressure.
I think, thanks, Gary. Sorry, just to add to that, and it goes back to the question about leadership measurement as well. It's really important, and we're very mindful of. It's very easy to become absorbed and focused on the technology and the AI, but really important to keep in mind the students and the person learning is still actually a person that has genuine feelings and the like. And not only do we need to set a baseline of what good looks like, our instructors need to think about what is the best way to interpret and then communicate data so it actually has the best impact as well.
Yeah, right.
Because at the end of the day, this is about training people to be at their best.
Yeah, that's the personal and ethical considerations that we need to have in the back of our minds about what we are doing to people and how we are allowing them to progress, motivating them, and providing them with encouragement to keep going, or cutting them off.
Fantastic, thank you. And Adrienne has a good question here in the chat. You showed some lovely feedback on things like dexterity, and you mentioned trying to use VR for some higher level skills such as critical thinking and teamwork. Have you used this in things such as emergency response or surgery scenarios?
In some of my own research, I tried to look at decision-making skill by analysing the set paths and the routines that some doctrine lays down, some standard operating procedure lays down, the conformance to that, and then the time taken to make those decisions. That sort of worked for a novice decision maker, but not for an expert decision maker, because an expert decision maker is going to look at a situation, they're going to analyze it, they're going to draw upon their mental models of past experiences, and they're going to look for patterns, and they do that pattern recognition, decision recognition process, and then apply their experience to what they are observing around them. That's the difference between an expert and a novice. The novice doesn't have that memory, and that's what we've got to put into the simulations to do that. So that's actually a really tough one that people try to do. They've been researching it for a very long time and still looking to find the right answer, I think.
Okay, great, thanks. There are a couple of comments in the chat as well about Monash offering simulation training for educators and a grad cert in clinical simulation, which sounds great.
Yep.
So it's good it's happening there. Graham has asked a question. There's lots of cool info and simulations shown were about honing and measuring efficiency. What about encouraging and learning from exploration and failure?
That's the point I was trying to make about the intervention and assessment and debriefing. Do you allow someone to progress to failure and keep trying, or do you intervene and stop them? I think there's great benefit in that explorative play, shall we call it, when you've got an AI engine that you can either turn on or off. So I can say, no, I want to work with the simulation now without guidance. I'm going to explore and figure out for myself. Then when I've got my confidence up, then maybe I'll turn the AI guidance on, and then I can get some feedback on how I'm actually performing and what I could be doing better. It's not binary. It can be on or off to suit where you are and what you're trying to do. So I think there is a role for that, yeah.
And just to add to that, it's flight simulation training is the best example where absolutely we can recreate all sorts of things. So in the event that there is a failure, so to speak, as in a student doesn't get it right, there is absolutely the opportunity to learn and debrief. But to Gary's point, much of that still comes back to the instructor and making the decision at the time. What is the best way? Is it let them finish and then provide that feedback, or is it to stop it and say, well, hang on, this is something that we need to provide now? And that can come down to one of the biggest challenges is not everyone learns in the same way. So we can't just look at all students and say everything, the right answer will be the same for everybody.
And this leads into the whole gamification of learning as well, because you can maybe have some proxy measure of performance that is available to the candidate that is simple and visual enough to guide and motivate them, but maybe not such that might develop the wrong sort of behavior in what they're trying to do. In trying to get the high score, they're taking shortcuts, they're not developing skills in the right sort of way. So have to be very, very careful of applying an in-game sort of motivational measure.
Yeah, fantastic. And there's not time maybe to cover every question, but there's a comment that Adrienne made about definition of success is always going to be dependent on a human decision as well. I think that sort of ties in with what you're saying. It's really up to the humans to understand what the data is telling us, how it can be used, and all those sorts of ethical and other considerations you've mentioned. I just wanted to flag that. Yep. The last question I think we've got time for, and then I will need to wrap up very, very quickly, so a short answer might be good. From Matt, could we maybe use GANs, G-A-N-S, and I'm going to plead ignorance to that one, to generate the challenging scenarios for the experts? If the difficult scenarios are being generated by other humans, they may not be as good as the expert. Or should we get the experts to design the challenging scenarios? Okay, so I think the question is really, do we need the experts to design the scenarios, or can we have people maybe not as skilled designing the scenarios so that the expert can learn where some of the gaps may be? And Matt, if I've misinterpreted that, let me know.
Okay, general adversative networks. Yeah, tough one. Where you've got highly procedural based situations where you've got intelligent actors and forces in a system, probably yes. But when you're looking at maybe other less computer generated scenarios like the human interactions and role play in, say, a clinical situation, I would say no, you need an expert to design them.
Fantastic, thank you. I think that's all the time we have for questions. We covered nearly all of them, which is really great. So I just wanted to again thank everyone for joining us here today, and especially to thank CAE, Justin and Gary. And just remind everyone that CAE is a partner of our Master of Simulation and Immersive Technologies program in the faculties of Arts, Design and Architecture. And I guess the point to note based on the conversation today that this program really is focusing on the human dimension in the use of these technologies and how we can effectively design immersive experiences to actually answer a lot of the questions that came up today. So something, if people are interested, we can follow up with you about that if you want more information. But importantly, we would love you to be able to fill in a 60-second survey. Remy has placed a link in the chat and she might be putting a slide up for us now. Very short survey, but we'd love your feedback because we want to do more of this in the future. And Justin and Gary, I'd also be keen, if we get a lot of interest from this, in maybe seeing if we can schedule a more informal kind of chat we can host to explore some of these ideas together, if you're open.
I'd love to get like a working group going where we can capture everybody's feedback and thoughts on this, because it will help improve what we do. It will help improve the material I deliver in the lectures that I provide you with. And that's got to be good for everybody. So more than happy to do that.
Fantastic. Thank you again, everybody. Really appreciate it. I hope you have a great rest of the day. And as mentioned, we will distribute the link to the recording. And Gary, if you include that other link you mentioned, I think people may find that of use as well.
Yeah.
Thank you very much, everybody. It's been a real pleasure, and we hope to see you again at a future event. Thanks very much.
Thank you.
Thank you all.